In this second part of matrices, we will discuss equality of matrices, algebra of matrices. In this, we will study addition of matrices, subtraction of matrices, and multiplication of matrices. Hello friends, you are watching YouTube channel Number Collage. This channel features easy to understand concept videos on mathematics. Now we will see what is equality of matrices. Two matrices of the same order are said to be equal if their corresponding elements are equal. For example, matrix 2, 4, 5, 1 is a 2 by 2 matrix which is equal to another 2 by 2 matrix 2x 4 6 x, which is also a 2 by 2 matrix. Since these two matrices are equal, their corresponding elements are equal, which means this 2x equals this 2. So that gives us 2x equals 2 or x equals 1. So here also we get this x equals 1, and the remaining elements are also correspondingly equal. Matrix 1 2 5 c 7 1 is a 3 by 2 matrix which is equal to another 3 by 2 matrix a 2 b 3 7 minus 1, which is also a 3 by 2 matrix. Since these two matrices are equal, their corresponding elements are also equal, which means that A equals 1 and B equals 5 and C equals 3. When two matrices are equal, their order also must be equal. This is important. Matrix, unlike the determinant, cannot be evaluated individually, but two or more matrices can be added, subtracted, or multiplied following certain rules. Addition of matrices. When we add two matrices, we add their corresponding elements. Therefore, it is important that the two matrices must have the same order. Add 2 1 3 5, which is a 2 by 2 matrix, to another 2 by 2 matrix minus 3 minus 1 5 minus 3, which is also a 2 by 2 matrix. We have to add the corresponding elements. So we will add 2 and minus 3, 1 and minus 1, 3 and 5, 5 and minus 3, which is also a 2 by 2 matrix. We get the resulting matrix after addition, which is minus 1 0 8 2. Add 3 minus 1 2 5 6 0, which is a 3 by 2 matrix, to another 3 by 2 matrix 6 minus 5 0 minus 9 3 minus 2, a 3 by 2 matrix. We have to add the corresponding elements of these two matrices. So we add 3 and 6, which is 9, minus 1 and minus 5, which will be minus 6, 2 plus 0, which will be 2, 5 minus 9, which will be minus 4, 6 plus 3, that will be 9, and 0 minus 2, that will be minus 2. So this is the resultant 3 by 2 matrix after adding these two matrices. So this is how addition of matrices carried out. Let us understand scalar multiplication of a matrix. You can multiply a matrix A by a scalar k to get a matrix Ka, which is obtained by multiplying every element of A by K. 2 multiplied by matrix 3, 2, minus 1 is a matrix obtained by multiplying every element of the matrix by 2, which will be 2 multiplied by 3, 2 multiplied by 2, 2 multiplied by minus 1. It will be a column matrix 6, 4, minus 2. Minus 5 multiplied by a matrix 2, minus 3, 5, 7, minus 1, 0, which is a 2 by 3 matrix. You will get a new matrix by multiplying every element of this matrix by minus 5. So it will be minus 5 multiplied by 2, minus 5 multiplied by minus 3, minus 5 multiplied by 5, minus 5 multiplied by 7, minus 5 multiplied by minus 1, minus 5 multiplied by 0. So the new matrix will be minus 10, 15, minus 25, minus 35, 5, 0. Root 3 multiplied by a matrix 7, minus 2, minus 2, minus 3, minus 5 will be a new matrix obtained by multiplying each element of this matrix by root 3. So it will be 7 root 3 minus 2 root 3 minus 3 root 3 minus 5 root 3. So this is known as scalar multiplication or scaling of a matrix. What is subtraction of matrices? Suppose matrix A is 3 minus 4 7 minus 3 and matrix B is 15 minus 3 12 13. We have to find A minus B and B minus A. Let's find minus A. It will be a matrix obtained by multiplying each element of A by minus 1. So it will be minus 3, 4, minus 7, 3. Matrix minus B will be a matrix obtained by multiplying each element of B by minus 1. So it will be minus 15, 3, minus 12, minus 30. Now to find A minus B is to add minus B in A. So A minus B will be same as adding minus B to A. So it will be 3 minus 4 7 minus 3 plus minus 15 3 minus 12 minus 13. That will be 3 minus 15 minus 12 minus 4 plus 3 minus 1 7 minus 12 minus 5 minus 3 minus 13 will be minus 16. So this is the matrix A minus B. Next we will find B minus A, which is same as adding B to minus A. So we write matrix B 15 minus 3 12 13 plus minus A, which is minus 3 4 minus 7 3. It will be 15 minus 3, which is 12, minus 3 plus 4 1, 12 minus 7 5, 13 plus 3 16. So this is matrix B minus A. If x is 5 minus 4 minus 3, 2. Y is 2 minus 6, 7 minus 9. We have to find 4x plus 3y. 4x will be 4 multiplied by the matrix 5 minus 4 minus 3, 2. It will be 4 5s are 20. 4 into minus 4 minus 16. 4 into minus 3 minus 12. 4 into 2 8. Next 3y will be 3 multiplied by 2 minus 6, 7 minus 9, which will be 3 2s are 6, 3 into minus 6 minus 18, 3 into 7 21, 3 into minus 9 minus 27. Now we have to find 4x plus 3y, which will be 4x, which is this matrix, 20 minus 16 minus 12 8, and 3y, which is this matrix, it will be 16 minus 18 21 minus 27. So it will be 20 plus 6 will be 26, minus 16 minus 18 minus 34, minus 12 plus 21, 9, 8 minus 27 minus 19. So this matrix is the value of 4x plus 3y. If A is minus 1, 2, minus 3, 0, 1, 2, B is 4, 5, minus 6, 3, 1, 2, and C is 5, minus 1, minus 1, 2, 3, minus 1. We have to find matrix X such that 3A plus 2B minus x equals c. First we will solve this equation for x. That will be x equals 3a plus 2b minus c. Next we find 3a, which will be minus 3, 6, minus 9, 0, 3, 6. 2b will be 8, 10, minus 12, 6, 2, 4. Now we will substitute values in this equation to get x. So x will be 3a, which is this matrix, minus 3, 6, minus 9, 0, 3, 6, plus 2b, which is this matrix, 8, 10, minus 12, 6, 2, 4, minus c, which is this matrix, so minus 5, minus 1, minus 1, 2, 3, minus 1. It will be minus 3 plus 8 minus 5, then 6 plus 10 plus 1, minus 9 minus 12 plus 1, 0 plus 6 minus 2, 3 plus 2 minus 3, 6 plus 4 plus 1. It will be 8 minus 8, 0, 17, minus 20, 4, 2, 11. So this is the matrix X. Now we will talk about matrix multiplication. We know that multiplication of two numbers is commutative, which means two numbers can be multiplied in any order. The answer will be the same, such as 2 multiplied by 3 is same as 3 multiplied by 2. But that is not true of two matrices. Matrix A multiplied by matrix B may or may not be equal to matrix B multiplied by matrix A, which means the order in which two matrices are multiplied is important. So let us write here, order is important. Suppose matrix A is of the order m by n multiplied by matrix B, which is of the order p by q. Here matrix A can be called pre-matrix and matrix B can be called post-matrix. Now this matrix multiplication is possible only if number of columns n of the pre-matrix is equal to number of rows of the post matrix, that is when n equals p. Therefore, whenever we start matrix multiplication of two matrices, we have to check whether number of columns of the pre-matrix is equal to number of rows of the post matrix. Then only we can proceed with the matrix multiplication. Now let us understand how matrix multiplication is actually performed. That is, performing matrix multiplication. Consider a matrix multiplication of 3 minus 2, 1, 5 minus 1, 3, which is a 2 by 3 matrix multiplied by a matrix 5 minus 3, 2, 1, minus 1, 0, which is a 3 by 2 matrix. Let us first confirm whether this matrix multiplication is possible. We find that the number of columns of the pre-matrix is equal to number of rows of the post matrix. Therefore, this matrix multiplication is possible. Now let us see how this matrix multiplication is actually performed. In the matrix multiplication, the elements in the columns of the post matrix are multiplied by the elements of the rows of the pre matrix and then added. That is, we will get 3 multiplied by 5 plus minus 2 multiplied by minus 3 plus 1 multiplied by 2. So that forms the first element of the resulting matrix. Now for the second element, we will multiply this 3 by 1 plus minus 2 multiplied by minus 1 plus 1 multiplied by 0. So that forms the second element of the resulting matrix. Next, we will multiply elements of the second row of the pre-matrix by the elements of the columns of the post matrix. So we multiply this 5 by this 5, so that will be 5 multiplied by 5, then minus 1 multiplied by minus 3 plus minus 1 multiplied by minus 3 plus 3 multiplied by 2. So that forms the third element of the resulting matrix. And finally, we will multiply the second column of the post matrix by the second row of the pre matrix. So it will be 5 multiplied by 1 plus minus 1 multiplied by minus 1 plus 3 multiplied by 0. So that forms the fourth element of the resulting matrix. We find that the order of the resulting matrix is 2 by 2. So it will be equal to 15 plus 6 plus 2, the first element, 3 plus 2 plus 0, the second element, 25 plus 3 plus 6, the third element, 5 plus 1 plus 0, the fourth element of the resulting matrix. So finally, the resulting matrix will be 23, 5, 34, 6. So this matrix, which is a 2 by 2 matrix, is the result of this matrix multiplication. If matrix A is minus 1, 3, 4, 5, 0, 1, and matrix B is 2, 1, minus 3, 4, 5, minus 1, find matrix AB and without computing BA, show that AB not equal to BA. Let us first confirm if the matrix multiplication AB is possible. Order of matrix A is 3 by 2 and order of matrix B is 2 by 3. Now since number of columns of matrix A equals number of rows of matrix B, this matrix multiplication is possible. So we write AB equals -1 3 4 5 0 1 multiplied by 2 1 -3 4 5 -1. The resulting matrix will be of the order 3 by 3. We will multiply columns of the post matrix by the rows of the pre matrix. So AB will be -1 multiplied by 2 plus 3 multiplied by 4. That forms the first element of the resulting matrix. Next, -1 multiplied by 1 plus 3 multiplied by 5. That forms the second element of the resulting matrix. -1 multiplied by -3 plus 3 multiplied by -1. That forms the third element of the resulting matrix. 4 multiplied by 2 plus 5 multiplied by 4. That forms the fourth element of the resulting matrix. 4 multiplied by 1 plus 5 multiplied by 5. That forms the fifth element of the resulting matrix. 4 multiplied by -3 plus 5 multiplied by -1. That forms the sixth element of the resulting matrix. 0 multiplied by 2 plus 1 multiplied by 4. That forms the seventh element of the resulting matrix. 0 multiplied by 1 plus 1 multiplied by 5. That forms the eighth element of the resulting matrix. And finally 0 multiplied by -3 plus 1 multiplied by -1 forms the ninth element of the resulting matrix. So the resulting matrix is a 3 by 3 matrix. So finally the matrix multiplication AB will be 12 minus 2 10, 15 minus 1 14, 3 minus 3 0, 8 plus 20 28, 4 plus 25 29, minus 12 minus 5 minus 17, 0 plus 4 4, 0 plus 5 5, 0 minus 1 minus 1. So this matrix is matrix multiplication AB. In the second part of the problem, without computing BA, we have to show that AB is not equal to BA. Order of matrix A is 3 by 2 and that of matrix B is 2 by 3. The order of matrix AB is 3 by 3. In case of matrix multiplication BA, the order of BA will be 2 by 2. 2 by 2. We have learned earlier that two matrices are equal if they have the same order. Since here matrix AB is of order 3 by 3 and matrix BA is of order 2 by 2, matrix multiplication AB will not be equal to matrix multiplication BA. If matrix A is 2 5 1 3 and matrix B is 3 minus 5 minus 1 2, we have to show that AB equals BA equals identity matrix I. So let's first perform AB. It will be 2 5 1 3 multiplied by 3 minus 5 minus 1 2. The matrix multiplication will be 2 multiplied by 3 6 plus 5 multiplied by minus 1 minus 5 2 multiplied by minus 5 minus 10 5 multiplied by 2 plus 10 1 multiplied by 3 is 3 plus 3 multiplied by minus 1 minus 3 1 multiplied by minus 5 minus 5 plus 3 multiplied by 2 6, which will be 6 minus 5 1, minus 10 plus 10, 0, 3 minus 3, 0, 6 minus 5, 1. So AB is an identity matrix I. Now let us perform BA. It will be 3 minus 5 minus 1, 2 multiplied by 2, 5, 1, 3. So it will be 3 multiplied by 2, 6 plus minus 5 multiplied by 1 minus 5, 3 multiplied by 5, 15 minus 5 multiplied by 3 minus 15 minus 1 multiplied by 2 minus 2, 2 multiplied by 1 plus 2 minus 1 multiplied by 5 minus 5, 2 multiplied by 3 plus 6. It will be 6 minus 5, 1, 15 minus 15, 0, minus 2 plus 2, 0, 6 minus 5, 1, which is an identity matrix I. AB equals BA equals identity matrix I is proved if matrix A is 2, 4, 4, 4, 2, 4, 4, 4, 2. We have to show that A squared minus 8A is a scalar matrix. Let us first find out A square from A. So A square will be matrix A multiplied by matrix A, or self multiplication of matrix A. So we write 2, 4, 4, 4, 2, 4, 4, 4, 2 multiplied by the same matrix 2, 4, 4, 4, 2, 4, 4, 4, 2. So we will multiply the first row of the pre-matrix by the first column of the post matrix. So first 2 2s are 4 plus 4 4s are 16 plus 4 4s are 16. Next 2 4s are 8 plus 4 2s are 8 plus 4 4s are 16. Next 2 4s are 8, 4 4s are 16, 4 2s are 8. So this forms the first row of our resulting matrix. Now the second row 4 2s are 8 plus 2 4s are 8 plus 4 4s are 16, 4 4s are 16, 2 2s are 4 plus 4 4s are 16. Next 4 4s are 16, 2 4s are 8 plus 4 2s are 8. This forms our second row of the resulting matrix. Now 4 multiplied by 2, 8, 4 multiplied by 4 plus 16, 2 multiplied by 4, 8. Next 4 multiplied by 4, 16 plus 4 multiplied by 2, 8 plus 2 multiplied by 4, 8. Now 4 multiplied by 4 is 16 plus 4 multiplied by 4 is 16, and 2 multiplied by 2 plus 4. So that gives us the third row of this resulting matrix. This resulting matrix now becomes 16 plus 16, 32 plus 4, 36. then this is 32, then 32 again. So that is our first row. Then second row is 32, then this is 32 plus 4, 36, then 32. The third row is 32, 32, and 16, 16, 32, 32 plus 4, 36. Now we will find this minus 8a. So minus 8a will be minus 8 multiplied by this matrix A, which is 2, 4, 4, 4, 2, 4, 4, 4, 2. So that will be, we have to multiply each element of this matrix A by minus 8. So it will be minus 16, minus 32, minus 32, minus 32, minus 16, minus 32, minus 32, minus 32, minus 16. We now have a square equals 36, 32, 32, 32, 36, 32, and 32, 32, 36. And we have minus 8a as minus 16, minus 32, minus 32, minus 32, minus 16, minus 32, minus 32, minus 32, minus 16. Now we will find a square minus 8a. So a squared minus 8a will be 36 minus 16, 20, 32 minus 32, 0, 32 minus 32, 0, 32 minus 32, 0, 36 minus 16, 20, 32 minus 32, 0, 32 minus 32, 0, 32 minus 32, 0, and finally 36 minus 16, which is 20. Now this is a diagonal matrix with its diagonal elements all equal. So therefore it is a scalar matrix. Friends, if you like this video, please click the like button. Share this video with your friends and classmates. Do subscribe this channel to get more videos of this type. See you in the next video. Until then, keep watching Number Collage. Thank you.